Welcome to G Fun Facts Online, where we dive into the incredible science and technology shaping our world. Today, we're taking to the skies to uncover the secrets behind one of the most impressive feats of modern engineering, the long-range military sortie. Imagine an aircraft flying for thousands of miles, deep into hostile territory, for missions that can last longer than a full day. This isn't science fiction. It's a symphony of advanced technology, incredible logistics, and sheer human will. So how is it all possible? Let's find out. The idea of strategic air power has changed dramatically over the last century. Back in World War II, the strategy was all about brute force. Think massive formations of B-17s and B-29s carpet bombing industrial centers, hoping to cripple the enemy's ability to wage war. Then came the Cold War, and long-range bombers became the flying leg of the nuclear triad, a constant, terrifying deterrent. But in wars like Vietnam, it became clear that widespread destruction wasn't always the answer. This led to a revolution: precision-guided munitions. The 1991 Gulf War showcased this new era of surgical strikes, where air power could dismantle an enemy's command structure with pinpoint accuracy, moving from a strategy of annihilation to one of paralysis. At the heart of these modern missions are aircraft that are truly on the cutting edge. Let's start with the engines. Early jets used turbojets, which were powerful but drank fuel like there was no tomorrow. The game changer was the turbofan engine, which is far more efficient and gives aircraft the incredible range they need. And the technology is still evolving. The next generation of fighters will use adaptive cycle engines, which can actually change how they work mid-flight, switching between maximum power and fuel-saving cruise mode. Of course, range doesn't matter if you can't survive the trip. That's where stealth comes in. Stealth technology is all about making an aircraft as invisible as possible to radar. This is done with two key tricks. First, shaping the aircraft with flat, angled surfaces to deflect radar waves away. And second, using special radar-absorbent materials, like a high-tech coat of paint. The pinnacle of this technology is the new B-21 Raider. It builds on the legacy of the iconic B-2 stealth bomber, but uses next-generation low-observable technology that not only makes it harder to detect, but also cheaper to maintain. But these modern bombers are more than just stealthy airframes. They are flying supercomputers. The B-21, for example, is built on an open architecture system. Think of it like your smartphone. Instead of building a whole new phone every few years, you just update the software to get the latest features. This means the B-21 can be easily upgraded with new sensors, weapons, and software to stay ahead of threats for decades. It's not just a bomber. It's an intelligence-gathering platform, a surveillance hub, and even a drone quarterback that can coordinate uncrewed aircraft in the heat of battle. Now, even with the most efficient engines, flying across an ocean is a tall order. The secret lifeline that makes these global reach missions possible is aerial refueling. The ability to top up the tank in midair is what gives these aircraft their incredible endurance, allowing them to stay on station for extended periods. This technology is also getting a high-tech upgrade. Systems are becoming automated, reducing the workload on pilots. And soon, we'll see uncrewed tanker drones, like the Boeing MQ-25 Stingray, which will free up crewed fighter jets for their primary combat roles. Pulling off a sortie like this requires a monumental support system on the ground. The U.S. military is developing a concept called Joint All-Domain Command and Control, or JADC2. The goal is to connect sensors from every branch of the military: air, land, sea, space, and even cyberspace, into one massive unified network. For a bomber crew, this means having access to real-time intelligence from satellites, ships, and ground troops, allowing them to adapt to threats and change targets on the fly. Finally, with all this incredible technology, we can't forget the most important component: the human element. The crews flying these missions endure grueling conditions, sometimes staying in the cockpit for over 20 hours straight, crossing multiple time zones. Pilot fatigue is a serious risk, affecting concentration and decision-making. To combat this, missions are carefully planned to include strategic naps, and cockpits are designed to reduce workload and enhance situational awareness. Ultimately, the success of these missions comes down to the training, professionalism, and resilience of the aircrews, who must manage these complex systems under extreme pressure. From the evolution of strategy to the engineering of sixth-generation jets and the critical human element, long-range air power is a stunning demonstration of a nation's capability. And as technology marches forward into an age of hypersonics and AI-integrated systems, the future of our power in the skies is set to become even more influential on the world stage. Thanks for tuning in to G Fun Facts Online.